Automotive processing these days is getting much more complex. And with that, we need a platform that's going to be able to provide that level of functionality. So, Cyril, could you tell us a little bit about the Renesas new R-Car platform? It's targeted for automotive, which is going to require things like ASIL-D certification.
Sure. So thanks, Bill, for having the opportunity to discuss our car and new product with you. First and foremost, when we look at the automotive market landscape, I would say one size does not fit all, meaning that we see mega trends in this industry increasing the demand for SoCs, and they are at large mass deployment of ADAS, a shift to data and software-oriented architecture, and last but not least, willingness from customers to shift step by step to a centralized car compute system domain-based with zones. So altogether, when we look at these mega trends, in terms of SoC requirement and product, we need to take away three things. Scale, because majority of global OEMs have a portfolio of products that range from entry to luxury cars. B, software development is extremely expensive, and we need to provide R&D efficiency to our customers. And last, domain compute centralized needs scalability. So with that in mind, we have taken the next step in our investment in our car after Gen 3 and Gen 4 with the Gen 5, which will be manufactured in 3 nanometer. And with two principles, scale with monolithic and multi-die chiplet capability, and provide software reuse across the car platform from entry to luxury. And scaling in mainly three areas that are required by our customers: scale the CPU performance for the application, scale at large what I would call GPU performance for all the user experience, display, cockpit, and last, scale in terms of AI, which is the core for ADAS processing and autonomy in the car. So that's the principle, and that's why we have invested and now releasing the first Gen 5 product we call X5H, which integrates the latest and greatest technology aligned with this strategy.
So the R-Car X5H is actually implemented on a 3 nanometer technology. Could you talk a little bit more about why that's important?
Yeah, thanks, Bill, for the question. Again, yeah, we are leveraging with the X5H platform at large Gen 5 the latest technology advantages. And let me go through how it translates to our customers, okay? First, it's the best performance to power efficiency. And especially in that era where cars move to EV, battery operation is extremely important. Having the best-in-class power for centralized compute is critical for our customers. So let's take an example compared to the next technology nodes. We can deliver 30 to 35 improvement over a 5 nanometer process, which is extremely important for customers. So we, on the top of these 3 nanometer bringing us best-in-class power, we are as well combining different low power mode techniques. So we can say that we can deliver to our customer non-liquid cooled, safety compliant central car computer, and that's extremely important and huge differentiation for our customers who will be designing with Gen 5.
Very good. Well, before we start diving into the chiplets architecture, let's talk a little bit about the base processor. What's the compute engine that is in the R-Car X5H?
So the Gen 5 architecture is based on ability to scale performance in multiple targeted processing needs. And I will take just a few examples because, as you can imagine, those are very complex architecture. But we have application CPUs integrated into multiple clusters of ARM Cortex A720A. And overall, we can deliver more than 1,000 KD MIPS with the X5H. So customer will be able to leverage this ARM Cortex-A architecture for their application CPUs. In parallel, we provide as well a boost in real-time processing with the ARM Cortex R52 architecture. Again, implemented and integrated in clusters that can support, true ASIL-B and D with lockstep functions implemented up to 60K DMIPS connected with large internal memory. So that's the real-time processing engine of Gen 5. And then we have four hardware accelerations, one being the AI accelerations with dedicated best-in-class power efficiency NPUs, and we can, with the X5H, deliver up to 400 TOPS. And then we have high-performance GPU cores that will be delivering up to 4 teraflops equivalent performance for graphic capability. And this is, supporting all the cockpits to visualization of ADAS. Then we will have video accelerations, codecs, multi 4K media streaming engines, offloading and accelerated by hardware. And last, we will have both a subsystem for camera that will be able to do the image processing and multi-megapixel camera systems. And on the other end as well, a subsystem for display that will be able to process and handle multi-display configurations with, up to 8K panoramic display support. Altogether, that's the core of the processing we have in Gen 5 and specifically X5H.
Now, the implementation of the NPU and GPU is done via chiplets. Could you talk about that and how the Universal Chiplet Interconnect Express comes into play?
So we have what we call both these vertical and horizontal scalability. I just want to make sure it's very clear. We have NPU and GPU integrated in what we call monolithic X5H. So by itself, these products will have GPU and NPU capability. And again, I mentioned up to 400 TOPS for the NPU and up to 4 teraflops equivalent GPU for the X5H. With that in mind, we have as well integrated chiplet extensions to the core or to the monolithic SoC and via the standardized UCIe die-to-die interconnect and APIs. So what it allows us is that as customer needs more flexibility to adapt the performance of the system to their needs, we have as well on top of the integrated capability, processing capability of X5H to scale both the AI and the GPU capability via chiplets. So extend above 400 TOPS, extend above 4 teraflops of GPU via chiplets. So that's really the what we call this vertical flexibility, that on the top of the monolithic SoC we can as well extend the performance via chiplet.
Now, this is very interesting in terms of architectures, because some of it, people have been looking at more distributed architectures. It looks like this particular chip is capable of handling almost everything within a smart car these days.
Yes, the Gen 5, I mean, one of the key pillar and is that we think this X5H is the first automotive multi-domain SoC that we are building in 3nm technology. So multi-domain means that nowadays, as OEMs are delivering or planning new architecture that will be more centralized and that will at some point integrate multi-domains, you need to have that capability. Okay, and that capability is really one of the key aspect of Gen 5 and specifically the X5H. We have on top of GPU cores, NPU cores, application cores, we have built in multi-domain compute capability within the architecture of X5H. And that's what we call the mixed criticality. Okay, so hosting multiple compute domains into a single SoC will require some guarantee for their respective specificities. If you think about IVI, you may only need to support QM, while if you think about a cluster, obviously running real-time OS, ASIL-B, and if you shift to even further ADAS, this has to support up to ASIL-B or D with high integrity and potentially some, safe OS supported. So altogether, there is already software methods like Apaverser that exist on the market, but hardware measure are really needed to maintain and to deliver that mix critically that is required for multi-domain. So we have designed and implemented deep hardware measure inside the Gen 5 and X5H, like region ID memory protections, quality of service stations that will allow customer to really implement multi-domain or fusion class of use case on the chip. Amongst, of course, the capability, the performance capability, you really needed that mixed criticality support for achieve this best-in-class multi-domain integration.
Oh, very good. Definitely an impressive platform. Thank you very much for filling us in on the details.